Close your eyes for a second. Imagine you're underwater, not a modern ocean, something much older, way older. The kind of ocean that existed before sharks had even figured out how to swim properly. You'd expect tiny things, right? Primitive little creatures, just figuring out how to exist. But that is not what you would find. Instead, drifting right toward you is a tentacled predator longer than a school bus. Its enormous pointed shell cutting through the water like a slow-moving missile. Behind it, a sea turtle the size of a compact car glides past without a care. And above both of them, something armored and ancient, a fish with a head built like a tank is surveying the reef below for its next meal. This was not the deep sea. This was everywhere. Reefs, shallow bays, open ocean. For hundreds of millions of years, the oceans did not just have giants, they were dominated by them. And here is the thing that makes it genuinely strange. Most of these giants had almost nothing in common. Different body plans, different eras, different diets. Yet somehow, they all ended up absolutely massive. So, what was actually going on? Why did prehistoric oceans keep producing giants over and over again across completely different time periods? The answer isn't what most people expect. It is not because of higher oxygen levels. That is a different phenomenon entirely. It is not because the ocean was warmer or because the animals back then were just built differently. The real answer has almost nothing to do with the environment at all. It has everything to do with competition. Specifically, a ruthless, relentless arms race that played out over hundreds of millions of years, one that almost always ended the same way. The winners got bigger. Then the only thing left to compete against was each other, and so they got bigger still. This is the story of prehistoric marine gigantism, why it happened, why it kept happening, and why a few descendants of these giants are still out there in the oceans today. To understand how this arms race started, you have to go back roughly 470 million years ago, so far back that nothing was walking on land yet. No dinosaurs, no reptiles, not even early amphibians trying to figure out legs. The ocean was the entire world, and it was ruled by one of the strangest apex predators that has ever existed. Picture a giant squid, but instead of a soft body, it is wearing a 10-foot dunce cap made of solid shell. That is essentially the Endoceras, the largest of the orthocones. These were cephalopods, relatives of modern squids and nautiluses, and the biggest ones stretched up to 20 feet long. Most of that length was hard, calcified shell. Real mass, not trailing tentacles padding the mass. Now you might be wondering how something this awkward became the apex predator of its entire era. The answer is simple: nothing else was bigger. The Ordovician seas were full of slow, simple life, small armored invertebrates, and primitive fish that had not fully worked out how to be fish yet. In that world, you did not need speed or agility. You just needed to be too large for anything to mess with. And here is where the arms race begins. Once orthocones became the apex predators, the only real threat to an orthocone was another orthocone. They competed with their own kind for food and territory, which meant that the bigger ones survived and the smaller ones did not. Generation after generation, they grew larger and larger. It was an evolutionary arms race against themselves. And it worked. Right up until faster, more agile predators arrived and made that giant, unwieldy shell a liability instead of an asset. When the orthoconies faded, the top spot did not stay empty for long. Into the void crawled the eurypterids, better known as the largest scorpions that ever lived. And before you picture a scorpion from your bathroom, know that Gigantism, the biggest of them, stretched over 8 feet long. It had claws, it had armored plating, and it absolutely ruled the shallow coastal seas of the Silurian period. People often assume these giants got big because of high oxygen levels, the same way insects grew large in the Carboniferous period. But the timing does not work. Eurypterids were already reaching enormous sizes millions of years before oxygen levels spiked. Their size had nothing to do with atmospheric chemistry. It was the same force that drove the orthocones, an arms race with no ceiling. After the orthocones declined, the entire ecosystem reshuffled. Eurypterids suddenly found themselves competing with early fish, new prey species, and each other, all at once. In that environment, bigger bodies meant more power, more reach, more ability to hold territory in the shallow seas where food was densest. The ones that scaled up survived. The ones that did not were eaten by the ones that did. It is not complicated. It is just relentless. By the Devonian period, the arms race had evolved a new wrinkle: armor. Everything in the ocean was developing thick bony plates, harder jaws, and better defenses. If your prey keeps getting more heavily armored, you have two choices: give up or evolve jaws powerful enough to crush that armor. Most animals gave up. Dunkleosteus did not. Dunkleosteus was a placoderm, a heavily armored fish, and the final boss of this era. Estimates put it anywhere from 20 to 30 feet long, with a skull that was essentially a solid block of bone, and a bite force that could shear through steel if steel had existed back then. Paleontologists have found Dunkleosteus fossils with bite marks made by other Dunkleosteus, and that tells you everything you need to know about what happened when the arms race runs out of other species to escalate against. The same pattern. Different animals, different era, same result. Grow until you are the largest thing in the water, then start eating each other, then grow some more. Step back and look at all three of these examples, and the pattern is almost impossible to miss. Orthocones, sea scorpions, armored fish, completely different body plans, completely different time periods, no shared ancestry to speak of. And yet they all ended up as giants, all for the same reason. The ocean is uniquely good at producing giants. Buoyancy means gravity barely matters down there, and an animal can grow to sizes that would collapse under their own weight on land. In prehistoric seas, the food supply was enormous. There was always something to eat, always another prey species getting bigger and forcing predators to grow in response. But the deeper driver was always competition. Every time a new species became the apex predator of its era, the only pressure left was inward, against its own kind. That pressure, over millions of years, produces giants every single time. The asteroid 66 million years ago did not just kill the dinosaurs. It wiped the ocean slate clean, erasing mosasaurs, giant marine reptiles, and most of the enormous prey species that supported them. The arms race essentially had to restart from scratch, this time with mammals in the driver's seat. If you look at what that restart produced, it is the same pattern playing out again. Sperm whales evolved into the largest active predators on the planet, specifically to chase giant squid. Giant squid grew longer and stronger, specifically to survive being chased. The leatherback sea turtle, a direct descendant of the lineage that produced Archelon, still reaches over 2,000 pounds. And the blue whale is, by mass, the largest animal that has ever existed on Earth. Bigger than anything the prehistoric oceans ever made. The arms race never actually ended. It just reset, with different players. Somewhere out there in the deep ocean, that competition is still quietly running, and we have no idea yet where it leads next. If you want to understand another side of ocean gigantism, the cold, pressure-driven version happening in deep water right now, check out our video on polar gigantism. It is a very different story, but the same obsession.